Okay, this lesson is entitled More Parallel Lines, primarily because we just want to pause for a minute at where we are in this unit and give you some practice with more complicated diagrams. One of the things that I found is we do a lot of practice with the simple diagrams, 2 lines cut by a transversal. But then on the SOL and on other exams, you often get multiple lines with transversals. So our essential question is, how do I solve problems with multiple lines? Okay, let's take a look here at number 1. The very first thing I'm noticing is that I've got 3 parallel lines, which I am going to highlight. And I'm actually going to extend my parallel lines because I have 2 different transversals going on. Right? I have a transversal here, and I have a transversal here. Okay, so if I look at this, and let's focus on the green transversal first, I have consecutive interior angles that are marked. Consecutive interior angles have to be supplementary. So 100 plus 2y plus x has to equal 180. If I look at my red transversal, again, I have consecutive interior angles, which have to be supplementary. So 3y minus x plus 110 equals 180. Now I'm looking at these 2 equations and I'm thinking, uh-oh, I have 2 variables. And that means I'm going to have to go back to Algebra 1 and systems of linear equations in order to solve this. So first off, let's clean this up and let's get this in standard form. The x term, the y term equals the constant. So I'm going to take this and I'm going to subtract 100 from both sides. And I'm also going to switch, I'm going to leave my x and my y alone actually. Why not? Okay, let's look at our red line. I need to get my x's and y's in a column so I can leave my y's and x's where they are, but I need to subtract the 110 from both sides. Now, we add these together. And the nice thing about this particular problem is when I go to add them together, the x's are going to cancel out. 5y equals 150, so y equals 30. I'm almost there. Take that y value and go back to one of these original equations. It doesn't matter which one. I'm going to pick the green equation. 2 times 30. Substitute for y and solve for x. So this is going to be 160 plus x equals 180. X equals 20 degrees. By adding multiple lines and adding an extra variable, we really increase the rigor or difficulty of this problem. And you have to pull on your Algebra 1 skills to be successful. Ooh, I like this one. Let's see. I've got some parallel lines, which I'm going to highlight and extend, mainly so that I can draw attention to my multiple transversals. I have this one in red, and I have this one in green. Using your straight edge to extend these can be really, really helpful. Okay, let's start by looking at the red transversal. On the red transversal, I have 30 degrees and x minus y. The relationship between those 2 angles is corresponding, and corresponding angles are congruent. So 30 is going to equal x minus y. There's nothing more I can do there. Let's look at the green transversal. The green transversal has the 5y and the 2x. Well, 5y and 2x are alternate interior, so they have to be congruent. 5y equals 2x. Now again, I have a system of linear equations. Let's see, I think this time I might use substitution to solve, because I can easily take my red equation here and add y to both sides. Should have left myself some more room. I'm going to draw an arrow down here. And if I add y to both sides, I have x equals 30 plus y. Now I can take this value and substitute in here for x. 5y equals 2 times the quantity of 30 plus y. Now that this is all one variable, I can solve it. Okay, my value for y is 20. I'm going to take that value and I'm going to stick it back into one of these equations. It really doesn't matter which one. I'm going to choose the red equation. When I add 20 to both sides, x equals 50 degrees. Ooh, that kind of looks like a parallelogram to me. Lots of possibilities. Well, let's read the problem. If AB is parallel to CD, so let's highlight those parallel lines. And I always extend them. That helps me see things a little better. Is 1 congruent to 5? Well, let's see. 1 and 5 are both on this transversal. Okay, so now that I've highlighted that, 1 and 5 would be alternate interior. And yes, alternate interior angles are congruent. So 1 is congruent to 5. Let's check 2 and 6. 2 and 6 appear at first glance to be alternate interior, but look at this. You have to go from the transversal to the parallel line, and this line AD is cutting me off at some random point. So I can't say that 2 and 6 are congruent. They're not actually alternate interior angles. That's a tricky kind of question to be asking. Let's take a look at number 4. Wow, lots of lines going on here. So I'm going to identify that transversal so it's clear. So let's just go left to right. 70 and 80. 70 and 80 would be alternate exterior angles, and alternate exterior angles have to be congruent. So A and B are not parallel. And I'm actually going to say A is not parallel to B. Now let's check A and C. A and C, let's see, 70 and 110 don't directly have an angle pair relationship, but my alternate exterior would be right here on C, and 70 plus 110 would have to form a linear pair and equal 180. Yeah, A is parallel to C in this particular diagram. Let's check A and D. A and D, the 70 and 100 would be same side exterior, which have to be supplementary. 70 plus 100, nope. A is not parallel to D. But wait, you have not checked all the lines. Now let's look at B and C. B and C, 80 and 110, those are consecutive interior. They would have to be supplementary, but these two add up to 190. So B is not parallel to C. What about D? 80 and 100, they don't have a direct relationship. But if I use corresponding angles to fill in 80 degrees here, whoops, that wasn't corresponding. I put that on the wrong side. This would be corresponding. 80 and 100 would have to be a linear pair. Those do add up to 180, so B is parallel to D. And I'm still not done. Let's take out this scratch work here, and let's look at C and D. 110 and 100, those are alternate exterior. They would have to be congruent. They're not, so C is not parallel to D. All right, so my answers right here. The rest of this just helps me keep track of whether or not I checked all the possibilities. One of the really wicked ways to put this on a test or a quiz is to make it multiple choice and start with letters D or E saying answers A and B, answers C, D, and E, all of the above, none of the above. This could be a wicked problem on a test or a quiz. Okay, last one, and boy, is that gorgeous. Let's see. We're saying the measures of angle 1 plus the measures of angle 2 equal the measures of angle 3 plus the measures of angle 4. Goodness gracious, we have so much going on. Let's see. Let's make ST red. That kind of brings that into focus for me. Let's make, see if those two are parallel, right? 2 and 3, if SX and YT are parallel, 2 would have to be congruent to 3 because they're alternate interior. 1 and 4, though, don't have any relationship here. Sneaky. That's not going to work. Let's try something else. Okay, they're saying 1 and 2 added together. So 1 and 2 added together is this entire angle. 3 and 4 added together is this entire angle. They are both on ST. That's probably my transversal. Remember, angles are formed from the transversal to the parallel line. Let's extend that. From the transversal to the parallel line. What if it's these two that are parallel? Okay, so putting those angles together, I have alternate interior angles. Wow. RS, which happens to be a ray, is parallel to TQ, which happens to be a ray. Don't be afraid to erase and start over. A lot of times what you first think just doesn't pan out on these more complicated diagrams. Okay, take a minute and write a summary on how to approach the more complicated diagram.